Assalamualaikum warahmatullahi wabarakatuh. My name is Rino Muhammad and today I will present my proposal, which is fabrication, functionalization and characterization of nanofiber from starch. In my content, there are 4 sections, which is introduction, literature review, methodology and expected outcome. Okay, now let's proceed to the introduction of nanofiber. Because of its unique properties, nanotechnologies that require the manipulation of nanoscale material are commonly used for science and engineering. Almost every industry such as electricity, electronic, agriculture, food and others have been advanced and modernized by nanomaterial due to its first, high specific surface area, second is lower porosity and ease to manufacture, and third is superior mechanical strength. There are 2 types of nanofiber, which is synthetic polymer and natural polymer. Natural polymer are biocompatible and biodegradable, which is critical for application in drug release and tissue engineering. Next, we go to the problem statement. As we know, starch is the second largest biomass source on earth following cellulose and is one of the sustainable society's most important renewable resource. However, our nanofiber from starch are effective, high quality, low cost and biodegradable properties. The objective of this research is to be able to fabricate poor starch nanofiber from corn, and second is to determine the appropriate solvent for native high amylose starch. Next, we go to the literature review. For the fabrication of nanofibers, the first one is electrospinning. It is a commonly used electrostatic fiber forming technology utilizing electrical force to manufacture polymer with diameter varying from 2 nanometer to multiple micrometers, utilizing polymer solution of both natural and synthetic polymer. Essentially, the device consists of 3 main components, which are a high voltage power supply, a spinneret and a grounded plate. The second method is by using ATR technique. Kane 2009 stated that by using this technique, it can be direct surface contact with the sample by reflecting the infrared beam with a crystal to generate an evanescent wave at the surface that can help in achieving surface specificity. However, there's still an argument happen where the ATR technique have limitation to itself, where the functional group cannot be detected when there is a presence of hydroxyl group in the solvent. Moreover, Jose G 2006 stated that this characteristic of water and in general of H2O molecule often lead to signal saturation and cause the detector to be corrupted. The third method is dry spinning. Dry spinning is the process of fiber forming which transform a solution of high vapor pressure polymer to a solid fiber via controlled spin line fiber evaporation. Heat transmission, mass transfer and tension on the filament are the main variable in dry spinning. Then we go to the characterization of nanofiber, which are tissue culture and controlled drug delivery. Tissue engineering including bone, cartilage, muscle, nerve, tendon and ligament has also been applied with electrospun scaffold to order to reduce host organism toxicity, inflammatory and immune response. Biocompatible materials are preferred to create electrospun scaffold. For the controlled drug delivery in pharmaceutical formulation, electrospinning can embed target compound in nanofiber based on encapsulation technique to serve as delivery system. A broad variety of functional compound can be distributed by electrospun nanofibers, including medication. Next, we go for the methodology. The first part is sample preparation. Spinning dope will be prepared by dissolving starch 15% in a 95% aqueous DMSO solution. Next, the starch dispersion is heated for about an hour and allowed to cool down at room temperature in a boiling water bath with continuous swirling. After the sample preparation, we go to the electrospinning part. A 10 ml syringe will be used with a 20 gauge blunt needle. The mat washed with ethanol and dried into a desiccator, which contain dry rite on the surface of the coagulation bath. This experiment carried out electrospinning at room temperature. Feed level will be set at 4 ml per hour, 7.5 cm spin distance, and 7.5 kV voltage. After that, we go to the post-spinning treatment. A sample of starch fibers mat is put in a watery ethanol solution at 50% during the warming process and heated for 1 hour at 70 degrees Celsius. Following which it is then washed with ethanol and dried as described. A sample of starch fiber mat on a metal mesh is placed in a desiccator with dry rite on a petri dish for the cross-connection treatment. The aqueous glutaraldehyde solution will evenly spread in petri dish with 10 ml of 25%. The desiccator is kept for 24 hours in an incubator at 40 degrees Celsius. The last part is expected outcome. The expected outcome of this research proposal is first, to produce nanofiber from electrospinning, to be able to fabricate full starch nanofibers from corn, and last, to determine the appropriate solvent for native high amylose starch. This is my work plan, and this is my list of reference. Thank you.